Find the volume of the solid obtained by rotating about the line x equals 2, the region bounded by the curves y equals x to the fourth, y equals 0. Y equals 0 means x-axis, and x equals 1. And we are using cylindrical shells. Okay, let's graph these three curves. So we have vertical axis, that's y or x equals 0, horizontal axis x, or this is y equals 0, and this is x equals 0. Here's the origin. Now y equals x to the fourth is a parabola, so we graph that. Okay, y equals x to the fourth, y equals 0, that's the x-axis, and the x equals 1. Okay, here's 1, so x equals 1 is a vertical line, x equals 1, so this part is 1. Now the region bounded by these three curves is this shaded region, okay, which extends from 0 to 1, and we want to rotate this about the line x equals 2. So let's draw x equals 2, 1, x equals 1, x equals 2 is here. Okay, this is x equals 2, and we want to rotate this shaded region about x equals 2 using shell method. In shell method, we draw a representative rectangle of a small width parallel to the axis of rotation. This is 2, so we want to draw a parallel. Let's take a small sample representative rectangle of width small width on x-axis delta x. Small width is delta x. That suggests the volume formula will be in terms of dx. Okay, due to this small width, it will be in terms of dx, and this small sample rectangle could be taken anywhere from 0 to 1, anywhere in between 0 and 1. So 0 to 1, we need to find the area of the cylindrical shell ax. Okay, and let me erase this part. When we rotate this small rectangle, okay, this is a sample rectangle, about this line, then we'll get a cylinder. Okay, outside of the cylinder, just the shell of the cylinder. Okay, let me draw over here. So we have a shell of the cylinder, and the axis of rotation is x equals 2, and this point is, let me draw, this is any point, the generic point on the curve x comma y. Y is given by x to the fourth, so x to the fourth. This point is in fact x to the fourth. Okay, same point. Now to find the surface area of the shell, it's the cylinder, a is given by, in terms of x, this will be in terms of x, 2 pi radius r h. Okay, and the radius is, this is the radius, and this is the height, which is same here. Okay, and our origin is somewhere here on this. This is the cylinder, and there's the origin. I'm just matching with the original graph. And now here to here, okay, this distance is 2. The axis of rotation is 2. So this is 2. So this distance here to here 2. So this part only is 2 minus this part. And this is, by the way, look, x port, so this is x. So the total is 2, and this is x. So the radius will be 2 minus x. So this will be 2 pi. R is 2 minus x. Now we need h. This is the height. Height is just x fourth, because this is x and x fourth. Okay, this is x fourth. Let's simplify. 2 pi is outside. When we multiply with x4 from distribute, 2x4, 2x to the fourth minus x fourth times x is x to the fifth. Okay, now we use this formula to determine the volume. Thus the volume is given by that formula, area of cylinder dx, and that is going from 0 to 1. This is given area we just found here. That's the area, surface area of cylindrical shell, and 2 pi can be pulled outside. A is 2x to the fourth minus x to the fifth dx. Let's integrate 2 pi outside. 2 is 2. Integration of x to the fourth is x fifth over fifth minus integration of x fifth is x 6 over 6, and we are evaluating from 0 to 1. Okay, 2 pi, and let's evaluate this function at 1. That gives 2 times 1 raised to 5, 1 over 5. 2 times 1 over 5, 2 fifth minus 1/6, that's the upper limit, minus plug in 0, that makes 0, lower limit. Okay, so 2 pi, 0 does not have any meaning here, just 2 fifths minus 1/6. Let's subtract 1/6 from 2 fifths. 2 5 6 30 is the common denominator, so 6 times 2, 12 minus 5, 12 this way, 5, 12 minus 5, 7, and 2 divides, this is 7, 2 divides 30 15 times, so 7/15 pi. So the final answer is 7/15 pi cubic units. Final.